So the key idea of this section is about data cleaning. Data cleaning as a process. We can see that when we want to do data cleaning, we need to detect there's a data discrepancy detection. How we can detect the discrepancy? The first is to use metadata. What is the meaning by metadata? It depends on the domain, it depends on the range, it depends on the dependency, and it depends on the distribution. Let's say I have this example. This example shows some noisy data. As you know that noisy data means there are some incorrect attribute values. The value is not correct. But how we can know that the value is not correct? From this data, postal code. Postal code should be a number. But it is not correct because someone put Y. So this Y is not correct. It's 455. So it is not in the particular range. We know that X maybe the person human can live the oldest person in the world maybe now is about 120 or 130. But it is impossible to get 445. So it is close because it is beyond the range. And maybe if you are a Korean, you can understand that the postal code in Korea should be 5 numbers. If it has 6 numbers, then this error. There should be some inconsistency. And you know that Korea already have the standard name of every city. So the city here, Seoul, Yongin, Busan. But this one, Seoul, without the E. So it can be also incorrect. And maybe for the foreign students, you may not be familiar with, but our school postal code is 17035. If our school 17035 and the city should be Yongin. So there is inconsistency. So we call this is there is no dependency. Okay. So the dependency is very important when we have the metadata. The data distribution. Okay. So this distribution is out of the normal data. Or we can say there is a range. So it is out of the range. We need to check the uniqueness rule. Uniqueness. Every data might be unique. Let's say if you have the postal code, it will be unique. One number will be only for one specific area. Consecutive rule. There should be a kind of sequence. If you choose something, it follows another thing. It follows another thing. For example, if you choose, you live in South Korea. Then maybe if you, for example, order a product from Amazon, okay, you want to get the product delivered to your home in Korea. So after you choose that you live in South Korea, there will be options. The options will be something related with the province, Gyeonggi-do, or yeah, it is Gangwon-do, and then maybe Jeollanam-do and Jeollabuk-do, and so on. So it is, when you select South Korea, it will show the province. After you select the province, Gyeonggi, for example, then there will be option about the city in Gyeonggi. Suwon, Yongin, Ansan. I don't know what else. Yeah. Asan and so on. Okay. So this means that we have a consecutive rule. One data will follow with another data after you know the big or the highest hierarchy. Or we can have the null rule. So maybe this one is okay. Why? Because it is null rule. For example, in some cases, you can make your gender as not visible. So in some of the website, if you want to be a member, they may ask you, what is your gender? You can choose male, you can choose female, or you can choose not to fill in. If you choose not to fill in, then the gender will be blank. So if it is follows with the null rule, then yeah, it is not noise. Some of the tools might be available. Let's say we call the data scrubbing. It uses simple domain knowledge. It means we can use the, in Korea, if you register your address, you can just write your address like here, where zero, and then it shows everything immediately, including the postal code, including the district, because we have the domain knowledge. Or if you use like the Microsoft Word, or if you use Hangul, whenever you type something, if the word is not correct, then there will be a spell check. So the spell check will automatically give you the correct words. So that kind of things, we call it the data scrubbing. It is to detect the errors and make corrections. We can also do the data auditing by analyzing data to discover rules and relationship to detect violators. So some methods we learned before, correlation or clustering to find outliers. So this is how we can detect the data discrepancy. When we are going to clean the data, so we can use some data migration tools. It means whenever you have your data, you can transform it. You can migrate the data from one database into another database. So it allows transformation to be specified, and usually we call it as ETL. Extraction, transformation, loading. Or yeah, people may can say just extract, transform, load. It allows user to specify transformation through a graphical user interface. So let's say I want to extract the data from the CRM. CRM is the customer relationship management. Or I want to extract the data from the ERP, from the enterprise resource planning. So after I extract the data, I would like to transform it. I can transform if it is the data about maps. So how can I transform it into a table? If the data is about the process, how can I transform it into a table? If the data is about routes, how can I transform it into a table? And after I transform into a table, I will merge it into one data warehouse. Usually, we will get the data at this stage. And after we have this data, we can do the analysis. We call this is the ETL, extract, transform, and load. Now, we finish with the data cleaning. We need to understand about the data integration. Oh, at the end of this class, there will be a learning check. The data integration. The data integration means we want to combine data from multiple sources. Multiple sources. So we have one data, we have another database, we have another database, and we want to combine into one single database. So we call this is the data integration. There are some ways. The first is to do the schema integration. The schema integration, if you understand the database, let's say we have table. We have two tables. This table is table A and this table is table B. And then we want to combine based on the customer ID. But in the table A, the attribute name is customer-ID. In the table B, the attribute name is customer-shop. Usually shop, it is the meaning by ID. So we can combine based on those two attributes if we have the schema. We can integrate the metadata from different sources. But there will be some identification problem. What does it mean? So, do you know Bill Clinton? So, he was US president before. In the media, people will quote his name as Bill Clinton. But actually, his full name is Bill W. Clinton. So in US, it is common to use only two names, Bill Clinton. But sometimes the media mention his name as William Clinton. So in your database, in one column, you may have Bill Clinton. In the other row, you have William Clinton, but they are the same person. Let's see again. I think you know the Korean previous president, Moon Jae-in. In Korean letter, it is obvious. Okay, the name is Moon Jae-in, like this one. But when it is in the alphabet, yeah, it becomes not clear because some media may write Moon Jae-in like this one, or another media will write Moon Jae-in with U, or another media will write Moon Jae-in just in. In one column, the name will have the Moon Jae-in the same with different letter, but actually they are the same. So this kind of problem may occur when you want to integrate the data. detecting and resolving data value conflicts. It means for the same real world entity, attribute values from different sources are different. And some possible reasons, because it has different representations. Yeah, like this one. Maybe some people think that U means OO. Okay. It has different representation or different scales. In Korea, you will measure the head. Okay. The head is 160 centimeter, 170 centimeter. But if you go to US, they will ask you about the head in feet. What is your head? Oh, I'm 6 feet, 25 inches. So they have different metrics. But it is the same column. This is it. So when we want to integrate, we need to consider this kind of problem. And also, there might be some redundancy. We call this kind of data, this kind of data will cause a redundancy. Maybe it shows different, but actually they are the same. So we can check this redundant data when we do the integration of multiple database by object identification. So the same attribute or object may have different names in different database. The same attribute. So if we have one column, it can have different names in different database. So like Moon Jae-in, different letters will cause a problem with the object identification. Or derivable data. One attribute may be derived attribute in another table. For example, annual revenue. So the annual revenue, we know annual. Annual means year. Yearly revenue. Then I can get this yearly revenue from the monthly revenue. If I have the monthly revenue, I can get the monthly revenue from the weekly revenue. If I have the weekly revenue, I can get the weekly revenue from the daily revenue. So I can extract those into the aggregation. So the redundant attributes may be able to be detected by correlation analysis and covariance analysis. So you already learned the correlation analysis. I will not discuss the covariance analysis, but we can just use the correlation analysis. Careful integration of the data from multiple sources may help to reduce or avoid redundancy. And it reduces the inconsistency and improve the mining speed and quality. So you already know the correlation analysis. For the nominal data, we will use chi-square. The larger the chi-square value means, the more likely the variables are unique. So last time we have the value is about 500 something. I forgot the 500 something. So it is very high value. And this high value, actually you need to look at the chi-square distribution table for a comparison. So it depends how many nominal data that you have. So there is a standard in the chi-square distribution table. because it is very high, so we can say that it is very highly related. So you already know the definition. And we also learn about the correlation analysis. If the data are numerical, we can use this correlation to measure how the data are correlated. If the R value is higher than 0, then those two attributes are positively correlated. If it is 0, then it is independent. If it is negative or below 0, then it is negatively correlated. Okay, now I would like to give you one example in the orange. So in the orange, I would like to make this more complicated process. We are going to merge 4 files. The files I already gave you in the E-class, they have 4 files. Employee salary, employee supervisor, employee date, and employee department. Okay. So the employee salary, we have the name Bob, Jake, Lisa, and Sue. And the salary is this one, this, and this. And there is an allowance. This one, this one, this one, and this one. In the second data, we have employee supervisor. It is group. Maybe this is the department. So the accounting department, the supervisor is Carly. In the engineering department, the supervisor is Guido. The HR department, the supervisor is Steve. This is the employee department information. Employee is Bob, and he is in the accounting. Jake is in the engineering, Lisa is in the engineering, and Sue is in the HR. Employee date, we have Lisa. She has been hired since 2004. Bob, he has been hired since 2008. Jake from 2012 and Sue from 2014. So we have 4 different tables. If you want to analyze this data, I need to combine, I need to integrate them. So how do we integrate those 4 files? In the E-class, I give you one file, practice merge. So in the orange, okay, you can save the files. You can go to file, and then you can save the files. And the file name is OWS. Okay. Let's say I want to make practice. Okay. practice01.ows. So you can save the file. So if I give you an assignment, then yeah, you can just submit this file. Okay. And if you have file like this one, practice merge, this is the orange workflow file. So you can just do drag and drop. You can drag this file and drop into the orange, and it will open the workflow in your orange. Okay. So it shows the workflow if the file is related with the orange workflow. Now I will explain about this flow. The first file, it is about the employee date.csv. The second file is about the employee department.csv. This file, it is the employee salary. So I can say like this one, this is only file. Okay, you can right click and you can rename it. So if you want to rename, it means you want to make more detail. This is file employee salary.csv. And this file you can rename, and I don't know what is this file. It is the employee supervisor.csv. So you can change the name. So this is the employee supervisor.csv. Okay. So every widget can have a very unique name. You can rename of the widget. So let's see the employee date. I would like to see this table. Okay, this is the employee Lisa. The hire date is 2004, Bob 2008, Jake 2012, and Shu 2014. Now I'm going to merge this data and the employee department. So I'm going to merge it. How can I merge it? I will concatenate the tables. Okay. I concatenate the tables. So we need to find what are the columns that we want to match. Based on those two different tables, here we have employee. And in the other table, we also have employee. So I want to combine those two data with the employee column. That's why here I would like to match the row based on the employee column, If I apply this one, then I can get the result. So Lisa is in the group of engineering and he has been hired in 2004. So now it becomes in one table. Now I would like to continue the merge. So the employee salary means I want to see the salary of the employee. But now we have the column name as name. So I would like to merge. I can concatenate the tables in, and the concatenation based on the column name, and the concatenation of the other column is the employee. So when I apply this one, I can see that now all the column has been combined. Box, the name is Bob and the employee is Bob. Of course, there are two redundant. You can remove it later if you don't need the attribute. So it is already combined with the salary and the allowance. So we can merge all those data into one table. Okay. If you do not want to show the two one, so you can just append the columns from extra data. So it means you can select either the name or the employee. So in this case, we can have only the name without the employee. So we don't have any redundant columns. Okay. But yeah, it depends on you. You can use the concatenate tables with row matching between name and employees. So you can see the two columns or the other way. Aggregate columns. In the aggregate columns, I want to combine two numerical data. In this case, I would like to combine the salary and the allowance. Let's say I know that salary is one column and allowance is another column, and I want to know the total salary. The total salary will be the summation of the two columns, salary and the allowance. So I can choose salary and allowance at the same time, like this one. And I can choose the operator. What are the operators? We can choose sum. We can choose product. What's product? Product is multiply. We want to multiply between the two colors, for example. Minimum, maximum, min. Min means I want to get the mean or the average between the two colors. Variance, I want to calculate the variance between the two colors. Median, I want to check the median between the colors. Because I want to sum, so let me choose the sum. And you can check. So the total salary, the total salary is the addition of the salary plus the allowance. 91,500 is from the 90,000 plus 1,500. So we use this aggregate column. And the final one, we have this employee supervisor. This employee supervisor, it shows the group and the supervisor name. So I want to merge. I want to merge by append columns from the extra data, and let's match the group and the group. So if we have the column group at the previous one, let's match it. After you merge this one, then you can get the whole data. We have all data. This is the employee. This is the hire date. Okay, employee and name, they are the same. Later we can remove it. And then the salary and the allowance, and then we have the total salary, and we know who is the supervisor. So we have originally 4 neuron files, but now we can combine it into one file. And we are ready for doing the data analysis. So yeah, let's say you have this data and you want to save this data. Okay, you want to save the data. So the save data means, yeah, you want to save into a file, whether you want to save into CSV or Excel. Okay. And there will be option like add type annotation to header. You want to auto save when receiving new data. Maybe you don't need to do this one because it will save automatically whenever you have a new data. So you can just try to save. And it will show you whether you want to save into a tab separated value or CSV value or pickle orange data or Excel and so on. Let's say I want to save into the CSV file. Maybe I can just put total employee, something like this. And if you save as total employee, then you can open your data in the CSV file. So it includes the details. Okay? And this kind of table might be confusing because it also includes the details of the data and the type of the data. So if you do not want to include just one, you don't need to add the type annotation to the header. So you can save and then check it. So it is in the CSV file that you can share to other people for further data analysis. Okay. Okay, I will stop here.